Hello! In this video tutorial I would like to present the scanning and data post-processing of the second technical part, which is the part of track suspension. As the result, we will receive the triangle mesh, which can be used for example for reverse engineering. For the scanning process, the Micron 3D green scanner with the field of view of 400 for 300 for 240 will be used. To fasten the scanning process, we will also use the rotary stage. Object will be scanned from 3 positions using the rotary stage. Additionally, we will also make 4 single scans. From the first position, we will scan the top internal and external surfaces of the object. The most important is to set up the scanner in position to the object, which allows to scan both sides. First, put the object on the rotary stage. Set up the position of the scanner. Remember about the lasers, they should cross in one point, so we know that we are in the center of the volume. Set up the proper angle of the scanner to the object. When the position of the scanner is set up, using the calibration plate define the axis of the rotary stage. After the calculation, put the object on the rotary stage and start the scanning process. We will scan the object around with the step of 30 degrees. To scan the bottom surface, change the position of the object on the rotary stage. In this position, the most important is to scan the bottom surface and the edges between top and bottom surfaces. We will scan the object also around, so the range is 360 degrees with step 30 degrees. For the scanning in third position, we would like to capture the bottom surface and the edges which we were not able to scan from previous positions. For additional scans, we have to change the position of the scanner, but because we will use the rotary stage only to rotate the object, without automatic measurement, we don't have to calculate the axis. We will use the single scan mode with the option of rotation of the connected rotary stage. As before, we will clean the groups one by one. For the first group, we will use the algorithms. For the rest, we will create the automation process using the operations and parameters used for cleaning of group 1. Go to Points tab and select the color option to delete darker points, which are less accurate and their quality is worse for creating the triangle mesh. Using the bar or by typing the value of 55 in text box, select the points, press OK button and delete the points. Go to Non-Continuities option and select the radius of 4 mm. We are going to use this operation 3 times with different radiuses to remove the non-continuities points on the edges. After the calculation, using the bar, change the value of select point further than to 1.4 mm. Repeat the operation also with the parameter 2 mm with selection of 0.8 and 1 mm with selection of 0.3 mm. After this operation, remove the contour of the clouds with one constant value. Go to Contour Options, press Select button, change the value from 1 to 0.3 mm, press Extend button, press OK and delete the points. Go to Group to remove the smaller groups of points. Set up the size of the groups as 10,000. After the operations, analyze the result of the post-processing of Group 1. For the cleaning of Group 2 and 3, we will create the automation process with the options and parameters used for cleaning of Group 1. Go to Automation tab and press Edit button. Press New button, set the name and select the operations and parameters from the list. Now I'm going to add those operations. After that, press Save button to save the automation process and add it to the list of available automations. Press OK to apply the changes. Run the automation process and wait for the results. Operations will be performed one by one. After that, I advise also to analyze the cleaning. Some of the points were removed manually for the better global alignment. I also know that I have the information of this part of the object on another scans. When the scans are cleaned, we have to align them to the one coordinate system. In this case, we will use manual registration of 3-point method for groups from 1 to 3. I set the group 1 and 2 as visible, the rest are invisible for better view of alignment in the manual alignment menu. Select as stable all the clouds from group 1 using the Control button and select them one by one, or using the Shift button select first and last cloud of the group to select all the clouds from this group. Select the clouds as fit from group 2, select common points of the groups and align them. Repeat the operation also for alignment of group 3. For the alignment of group from 4 to 7, we will use the option of curvature alignment. In this case, find the stable cloud from group 1 to 3, which has the information of common areas on the scans. Select the cloud from group 4, set up the parameters and press Align. Repeat the operation for the rest of the clouds. After alignment to one coordinate system, the global registration should be performed to find the best positions of the clouds between themselves. In fitting series, add rejection radiuses for 1 and 0.5 mm to minimize the moves and rotations of the clouds. Change the search engine from random to all points with threshold 10. Every 10th point of the cloud will be selected for the alignment. As the result, we will have more points counted for the alignment, but the time of alignment also increases. The maximum error is about 40 microns. After global alignment, they also advise to check the quality of alignment. Before creating the triangle mesh, I repeat the operation of removing the contour to avoid the situation of creating a triangle mesh with the spines. If the clouds are cleaned well, also with removing the points manually, it is not necessary. To create the triangle mesh, go to Triangles tab. Select all the visible groups from the model tree and press the Create button. Make sure that Optimized Algorithm is selected and press the Create button. As you can see, the triangle mesh is created. Of course, there are some holes we can fill using the option in SMARTTECH 3D Measure, or we can rescan this part of the object and align the cloud to the rest of the clouds.